Hey Bram Chemistry Kids, it's Miss Morel, and today we are going to look at the section 11.1 of chapter 11 on stoichiometry. So kicking this off, just as a reminder, there are some videos that teach you the basics of stoichiometry on the daily calendar, links to that, and you also have access to the book in Google Classroom. So take a look at those, come see me if you have questions. So this first question, the study of quantitative relationships between the amounts of reactants and the amounts of products is called stoichiometry. That is true. Okay, stoichiometry is based on the law of conservation of mass. You bet, that's true. It's chemistry. We use the law a lot. In any chemical reaction, the mass of the products is less than the mass of the reactants. We know that that's absolutely not true, that we follow the law of conservation of mass that says it would be the same, so that's false. All right, the coefficients in the chemical equation represent not only the number of individual particles, but also the moles of particles, and that is indeed true. The mass of each reactant and product is related to its coefficient, so that is true. So if we balance it out, it is related, so that's true. All right, we go down here to this chart and we see that we have methanol. So methanol is right here. Here's its formula. And so it wants to know the number of molecules. So to figure that out, we just look at the coefficient and we have 2. And when it asks for the number of moles, that's just the exact same thing. So if we have 2 molecules, we have 2 moles. And then as far as the mass goes, we add that up. And so carbon, it weighs about 12 plus hydrogen weighs 1 for each one of these, but we have 3 of them, so we'll do 3, and this is just an approximation. Oxygen is 15.99, so we're going to round that to 16, plus 1 more for this oxygen. So if you added that together, and then you were to multiply that times 2, because we have 2 of those, you should come up with about 64.10 would be the perfect answer if you didn't round those. So about 64. Here we'll take a look at oxygen. So oxygen, we look, and we have a 3 here in front of it. So we'll put a 3 here, which means we also put a 3 for the number of moles. Now oxygen we know weighs about 16, but there are 2 of them. So 16 times 2 would be 32, which we can see here. But then we are going to multiply that by 3. So when we multiply that by 3, we come up with 96.00 approximately. Then here, carbon dioxide. So if we look at the product side, we see that. And so there are 2 moles of that. So we'll put a 2 there and a 2 there because there it's just the same. And since there are 2, we're going to multiply this number by 2. And so then we would come up with 88.02. Then lastly, we have water. So we can see we have 4 moles or molecules of that. So we'll put a 4 there and a 4 there. We're going to multiply this number, which is the weight of water, times 4, and we will come up with 72.08. So we completed that chart, and hopefully you're feeling good about that. Next, what are the reactants? So that would be our items on this side. So we know that CH3OH and O2. Our products are on this side. So that's CO2 and water. Hopefully you guys are all able to look back and recognize that this is a combustion reaction. So we've got a hydrocarbon and oxygen that's going to burn. You're going to get carbon dioxide and water. What is the total mass of the reactants? So we could add these numbers together that we have over here. And so when we add those together, we would come up with 160.1. And if we were to find out the total mass of the products, we would add these and we would find out that we come up with the exact same thing. So that's great news. That means we followed the law of conservation of mass. How do the total masses of the reactants in the products compare? They are equal. So that's great news. We did very well on that page. Flipping to the back side, we'll take a look at that. So what is a mole ratio? So a mole ratio, that is just a ratio between the different compounds in a chemical reaction. So we'll just write that down. So ratio between compounds in a balanced reaction. So we have to make sure that it's balanced. And it's between moles. So we look at mole to mole ratios. Now, how is a mole ratio written? A mole ratio is written as a fraction. Okay. Predict the number of mole ratios for this reaction. So all that we're going to do is we're going to add this up. 6 plus 1 is 7, plus 3 more, plus 2. If we add all of that up, we come up with 12. Now, what are the mole ratios for this reaction? So when we look at that, we could do 6Na over 1 Fe2O3. That's one of them. We can do 6Na to 3Na2O. We could do 6Na to 2Fe, and so on. So you can do all of these. And so that is how you would calculate that. So you just keep going. You do 1 Fe2O3, 2 every 6 Na, and you keep going. And so you should end up with 12 different combinations. And so that's how you calculate that. So keep going. You guys should be able to do those. Then it says, what is the mole ratio relating to sodium to iron? So if we relate sodium to iron, we can find sodium here. There are 6 moles of that to 2 moles of iron. So we just write down 6 moles Na to 2 moles Fe. So that's our line. What is the mole ratio relating iron to sodium? So that would be 2 moles Fe to 6 moles Na. Now, like fractions, you could reduce this, but in chemistry, we don't have to do that. Which mole ratio has the largest value? And so the largest value would be the 6 moles. So if we come up here, it would be the 6 moles of Na to the 1 mole of Fe, because that's the largest ratio. 6 divided by 1 is 6. So 6 moles Na to 1 mole Fe2O3. All right, hopefully that helps you guys. Take good care. Thanks so much for watching.